Under a tranquil night sky where stars twinkle like distant beacons, in this very moment as you and I sit together, we revisit the eternal question that humanity has pondered and repeated for thousands of years. Far beyond, in the endlessly vast expanse of the universe, might there be beings similar to us who are living their lives? Could there exist other civilizations, much like the human inhabitants of Earth, capable of thinking, feeling, and dreaming? From ancient fairy tales to the most cutting-edge scientific debates, we have endlessly explored this theme. Yet the astonishing reality is that as of today, November 19, 2025, we have yet to uncover even a single piece of irrefutable evidence to clearly prove the existence of extraterrestrial civilizations. There is not one sharp photograph, no inexplicable radio signal that defies explanation, and not even a fragment of a spaceship that has crashed onto someone's farm which the entire world could universally acknowledge. Rumors surrounding Area 51 or tales of unidentified flying objects that have supposedly circled the skies for hundreds of years continue to circulate without end, but such accounts remain confined to the realm of mere possibilities and have failed to fully persuade the mainstream scientific community. Why does this silence persist for so long? Is there an invisible veil that separates us from them? Or perhaps they themselves are deliberately striving to avoid being discovered by us? The origins of this narrative trace back to the summer of 1950 at the Los Alamos National Laboratory in the state of New Mexico in the United States, during an ordinary lunchtime gathering among physicists. At that time, luminaries of the era such as the brilliant physicist Enrico Fermi, along with Edward Teller and Herbert York and several others, were seated around the table. They shared laughter over a humorous comic strip that playfully blamed extraterrestrials for the mysterious disappearance of trash bins on the streets of New York, and the conversation gradually shifted to recent reports of flying saucer sightings. The atmosphere remained light-hearted and enjoyable, filled with the clinking sounds of forks and knives and the aromatic scent of coffee wafting through the air. Then, abruptly, Fermi fixed everyone with a piercing gaze that silenced the group, and he posed the question, "So where are they, exactly?" This straightforward utterance gave birth to one of humanity's greatest enigmas, known as the Fermi paradox. This paradox highlights an evident contradiction. First, the universe is so immensely large and ancient, teeming with countless stars and planets, that the notion of intelligent life emerging solely on a diminutive world like Earth appears almost inconceivable. Second, despite this, we have detected absolutely no traces of them. Not a single signal, not one probe, and not even a colossal structure such as a Dyson sphere or a space bridge. To grasp the scale of the cosmos more tangibly, consider that as of 2025, astronomers estimate the observable universe contains approximately 2 trillion galaxies. Our own Milky Way galaxy alone harbors between 300 billion and 400 billion stars, and through missions like the James Webb Space Telescope and others, it has been revealed that nearly every star is orbited by planets. Within the Milky Way alone, the number of planets situated in habitable zones where liquid water could exist reaches into the hundreds of billions. In recent developments, the James Webb Space Telescope has employed direct imaging techniques to detect its first exoplanet in this manner, capturing the Saturn mass world-designated TWA-7b orbiting the young star TWA-7. Furthermore, in the atmosphere of the exoplanet K218b, methane and carbon dioxide have been identified, heightening expectations for biosignatures, while traces of giant planets have been found in the nearest stellar system to our Sun, such as Alpha Centauri, underscoring the rapid advancements in exoplanet research. Building on these strides, as of November 2025, the James Webb Space Telescope has delivered even more groundbreaking revelations. For instance, it has produced the first three-dimensional atmospheric map of the scorching gas giant WASP-18b, enabling scientists to delve deeper into the dynamics of distant worlds' weather patterns and compositions. Additionally, fresh observations of TRAPPIST-1e, an Earth-sized planet nestled in the habitable zone of a nearby red dwarf star, have unveiled potential clues regarding its atmospheric retention, fueling optimism for detecting signs of habitability. Moreover, compelling evidence has emerged for a massive gas giant orbiting Alpha Centauri A, the Sun-like star closest to our own, gathered via the telescope's mid-infrared instrument, bolstering the prospect that neighboring systems may conceal viable worlds for life. In June of 2025, The telescope achieved a milestone by directly detecting and imaging a novel exoplanet named TWA7b, marking a pivotal advancement in direct observation capabilities. Other notable finds include the circumbinary planet Bebop 3b, identified through radial velocity measurements, representing the inaugural such discovery via this method, and the enigmatic 14 Hercules C, a colossal, frigid world unlike any previously observed, which challenges preconceptions about planetary formation in cooler environments. The telescope has also scrutinized moon-forming disks encircling massive young planets, offering unprecedented glimpses into the early stages of satellite development around extrasolar worlds. Despite this surge in planetary detections, evidence of intelligent life remains conspicuously absent. Even if the probability of intelligent life emerging is exceedingly slim, positing it at a mere 1 in 100 million, the Milky Way should still host anywhere from several million to tens of millions of civilizations. So why does the universe remain so profoundly quiet? In 1961, Frank Drake unveiled the renowned Drake equation, a framework for estimating the number of communicative civilizations within the Milky Way. This equation multiplies 7 key factors: the rate of star formation each year in the Milky Way, the fraction of those stars possessing planets, the average number of planets per system lying within habitable zones, the likelihood of life arising on such planets, the probability that life evolves into intelligent forms, the chance that intelligent life develops technology capable of broadcasting radio signals, and the average duration such a civilization persists while transmitting those signals. Depending on the values assigned, outcomes range from a handful of civilizations to tens of thousands, yet Fermi's query endures: where are they? As of 2025, contemporary refinements to the Drake equation incorporate the latest empirical data, revealing a more conservative outlook. For example, a recent model integrating cosmic expansion rates and updated star formation statistics suggests that the nearest extraterrestrial civilization might lie as far as 33,000 light-years distant, as derived from Europlanet analyses, emphasizing how vast distances continue to thwart detection. The SETI Institute has sponsored recalibrations using observations from modern telescopes, indicating that the tally of communicative societies could be lower than prior estimates, influenced by variables like atmospheric stability and the longevity of technological societies. These iterations not only hone the formula's precision but also weave in interdisciplinary threads from astronomy, biology, and sociology, reminding us that this pursuit transcends mere computation to probe the essence of existence itself. Intriguingly, a November 2024 study, now influencing 2025 discussions, proposes augmenting the equation with parameters for dark energy density and multiverse considerations, potentially implying our universe may not be optimally tuned for prolific life, further dimming prospects for widespread intelligent signals. Explanations for this enigma abound, but today we delve deeply into 3 particularly chilling hypotheses that not only account for our apparent solitude in the cosmos but compel humanity to introspect profoundly. The first is the dark forest hypothesis. Envision the universe as a pitch-black forest under the cover of night. Within its depths lurk innumerable hunters, each armed with rifles, ravenous with hunger, and uncertain whether fellow denizens are allies or adversaries. In such a scenario, upon hearing an unfamiliar rustle, would one proclaim their presence and friendship aloud? Or would they hold their breath in silence, striking first if necessity demands? This concept springs vividly to life in the novel Dark Forest by Chinese author Liu Cixin, though antecedents appear in the 1990 book Killing Star by Charles Pellegrino and George Zabrowski, who posited that any interstellar-capable civilization, confronting a resource-scarce universe, would perceive others as latent threats, opting for stealth or preemptive strikes. The terror lies in humanity's inadvertent beacon. For nearly 2,000 years, we have broadcast radio waves skyward, commencing with radio and television transmissions in the 1930s, augmented by military radar pulses, propagating at light speed. By 2025, our signal sphere has expanded beyond a 200 light-year radius, enveloping tens of thousands of stars. We have ignited a torch in the shadowed woods. This underpins warnings from luminaries like Stephen Hawking and Carl Sagan that dispatching SETI messages constitutes humanity's most perilous endeavor. In October 2025, Researchers from Universe Today theorize that galactic empires might cluster at the Milky Way's core, where stellar density peaks, elucidating our silence as a byproduct of attenuated signals over immense gulfs of space and time. The second is the rare Earth hypothesis. As elaborated in the 2000 book Rare Earth by Peter Ward and Donald Brownlee, microbial life may proliferate across the universe, yet ascending to multicellular animals, and thence to intelligent beings, exegates an improbable cascade of conditions. These encompass a stable star akin to the Sun, precise positioning within the habitable zone, an orbit free from tidal locking, a substantial moon like Earth's to stabilize axial tilt and foster gentle seasons, an outer gas giant such as Jupiter to deflect asteroids, a robust magnetic field shielding against solar winds, tectonic plate dynamics facilitating carbon cycling, and opportune accumulations of oxygen. Earth's fortuitous alignments must converge flawlessly. Among the thousands of exoplanets unveiled by the James Webb Space Telescope, none mirrors Earth impeccably, lending credence to this view. Earth-like worlds may be exceedingly scarce in the Milky Way, perchance unique. The third, and most heart-wrenching, is the Great Filter hypothesis. Proposed by Robin Hanson in 1996, this theory posits a monumental barrier on the trajectory from rudimentary life to interstellar civilizations, one that scarcely any surmount. Earth's chronicle attests, we have endured 5 mass extinctions. The inaugural, roughly 440 million years ago, the Ordovician-Silurian extinction, wrought by global glaciation and abrupt sea level fluctuations, eradicated 80% of species. The second, approximately 370 million years ago, the late Devonian extinction, stemmed from oceanic oxygen depletion over protracted epochs, claiming 70% of species. The third, and most cataclysmic, the Permian-Triassic extinction, dubbed the Great Dying, unfolded 252 million years ago amid Siberian volcanic eruptions, which demolished the ozone layer and induced global warming, extinguishing 97% of marine species and 70% of terrestrial vertebrates. The fourth, around 200 million years ago, the Triassic-Jurassic extinction, triggered anew by volcanism and ocean acidification, wiped out 80% of species. The fifth, 66 million years ago, the Cretaceous-Paleogene extinction, precipitated by a 12-kilometer asteroid impact unleashing tsunamis, wildfires, and nuclear winter, annihilated 76% of species, including dinosaurs. Humanity eked through these gauntlets as fortunate survivors. Yet ecologists now herald a 6th mass extinction underway, unprecedentedly self-inflicted by one species, us. Per the International Union for Conservation of Nature's freshest data, over 1 million species teeter on extinction's brink, with rates accelerating hundreds to thousands-fold beyond geological norms. The Amazon rainforest forfeits tens of thousands of square kilometers annually, coral reefs succumb to bleaching, and European locales have witnessed insect populations plummet 97% in mere decades, per studies. Should the Great Filter loom ahead, self-annihilation via nuclear war, climate upheaval, rogue artificial intelligence, or engineered pandemics beckons. Thus the cosmic hush. Most civilizations crumble ere venturing beyond their galaxies. In September 2025, an R14 preprint advanced the DLC hypothesis, positing that post-singularity collectives might transcend physical expansion, rendering interstellar outreach obsolete and resolving the paradox through digital liberation rather than conquest. Moreover, November 2025 has witnessed SETI Institute advancements, including the integration of NVIDIA's IGX Thor platform at the Allen Telescope Array for real-time artificial intelligence signal processing, exponentially enhancing anomaly detection amid galactic noise. Concurrently, revisions to post-detection protocols underscore ethical imperatives for verified contact, while debunking viral rumors of an alien arrival this month as unsubstantiated astronomical transients like the interstellar visitor 3I Atlas, approaching perihelion on December 19 at 270 million kilometers, far too remote for visitation. What sentiments does this tale evoke in you? Each contemplation of it instills in me the duality. We may embody a cosmic miracle, yet teeter upon peril's precipice. Our recourse lies in cherishing this resplendent blue orb and mending our inflicted wounds. Should a distant reply to our signals arrive someday, we ought to extend open palms, not clenched fists. Gaze upward at the stars this instant. Their glow hails from antiquity, yet might flicker as silent torches aflame. Solitary or not, we persist here, vital and vibrant, weaving cosmos's splendor into shared narratives. Gratitude for traversing this protracted discourse to its close. May it impart trepidation mingled with amplified devotion to Earth. Until our next cosmic chronicle. Slumber peacefully.